Let's take a look at how the strategies for managing a medium play out in the case of cable internet. And it's going to turn out that many of the strategies are used all at once. In the case of cable internet, several houses each has a modem connected to the same physical wire here that's also connected to a CMTS. That is the cable modem termination system. The CMTS is in charge. It's going to be managing this shared wire between all of the houses. That wire is able to carry a number of frequencies, carry separate signals at different frequencies. So the first thing we do with this protocol is we split that wire into those multiple frequencies, which is an example of FDM, frequency division. In the original US cable modem spec, these channels were 6 megahertz apart. It turns out at something like 705 megahertz, 711 megahertz, and so on. At least for the download channels, that is the channels going from CMTS to the modems in houses, and some of the channels, like in the 30 megahertz range, are for upload. So these different channels are allocated, some for download, some for upload, and more of them are allocated for download than for upload. This is based on the idea that when you're at home, you are watching Netflix a lot or downloading a lot from the web. You do have to upload, like the request for which movie to watch or which web page to browse. And sometimes you do upload videos to YouTube, but most of the network use at a home is download, and so most of the frequencies are allocated to that. So this is a case of adapting not only to the medium, but to the use of that particular medium. On the download side, the CMTS is fully in control. It's the only one writing on the download side, so there's not much negotiation to be done. It can allocate the frames to those channels as it sees fit. Every modem at all the house, they're all on the same wire, so they're all going to see the same frames, just like original Ethernet, where all the nodes were on the same wire, and they can pay attention to the address in that frame to see whether they should use the frame or discard it. So we don't even need slots because, again, the CMTS is totally in control. These modems at the houses, they just need to be able to recognize coherent frames, not necessarily synchronized on a particular boundary. On the upload side, we are going to use time division multiplexing because we have multiple cable modems that are all sharing that wire and that need to communicate. So we do need a form of negotiation, and the first step of that is going to be the time division. We have multiple channels to work with perhaps, but instead of allocating a channel to a particular modem, because again, that would be limiting if one modem doesn't have anything to upload, we will have slots that these different modems try to use. So now we have a choice of strategies for how to say whether a modem is allowed to use a slot. In the cable modem protocol, DOCSIS, then it's going to be turn taking, where the CMTS is in control, and it is basically going to take requests from the modem and allocate slots to those modems. So mixed in with the download stream here, messages from the CMTS to the modems, it's going to say, okay, blue and green, you are allowed to communicate in the next group using these particular slots. Earlier, it had said that orange and red could communicate, and that's why these orange and red upload frames are here. So the CMTS tells modems when they are allowed to use these upload slots. But then how does it know which ones to allocate? How does it know, how does it poll the modems, in other words? And the answer is that some of these upload slots are not ever allocated. They're periodic slots that the modems are supposed to use to send requests on. In this particular period here, both green and blue said that they had data to send, and that's why the CMTS allocated green and blue some slots in the upcoming upload slots. These modems can't use these gray slots for regular update. They'll never be scheduled. Those are the ones they should use to request an update. Remember that one of our problems with this turn-taking polling based on a leader was that the leader always had to be up, and what happens if they go down? In the case of the cable modem, the CMTS always has to work, because if it's not running, the whole line is broken, and so it's okay to rely on this centralized scheduling by the CMTS. There's still the problem of how these gray slots get allocated, because that's where these modems are deciding that they have data to send, and the CMTS doesn't know about that. The way that works is that a modem declares its interest to send data without trying to consider whether anyone else is using that. It'll pick some channel, send a message on that channel. If there is a collision, it doesn't actually detect the collision directly. Instead, the fact that the CMTS never scheduled it as a an upload slot, the next time it sends out these messages, should be taken as a sign that there was a conflict, that the request didn't get through, and that it should be retried. And then for scheduling a retry, we use the usual strategy of a random delay, waiting a random number of these gray slots before trying again, and randomly picking a channel to put that request on. So the slots are going to be fairly small for the upload channel because that gives us more opportunities to declare on the modem side that they want to upload data. But at the same time, these gray slots are only going to be a small fraction of the slots, so that most of the time we get to use the upload slots for sending useful data. So again, you see that this DOCSIS protocol for cable internet manages to use many of the strategies that we talked about. It has some turn taking, it has some frequency division multiplexing, it has time division multiplexing, it has collision detection and random retries, all in one implementation of the link layer.